In this example, we're going to look at evaluating cotangent inverse of -1/2 with a calculator. So my calculator doesn't have cotangent inverse in it, and so I need to manipulate it so I can use my calculator. So the first thing that you want to do, let theta equal this cotangent inverse of -1/2. So recall cotangent inverse, that theta value had to be between 0 and pi. So we need to keep this in consideration. If we get back a negative value for our answer for theta, and then we know that it has to be in the second quadrant for this cotangent inverse. Okay, so now that we let theta equal cotangent inverse of -1/2, let's get rid of the cotangent inverse. And so we can undo that by taking the cotangent of both sides of our equation. So we get cotangent theta is equal to cotangent of cotangent inverse of this -1/2. So cotangent theta is equal to -1/2. So let's rewrite cotangent theta with its reciprocal function. So cotangent theta is the same thing as 1 over tangent of theta. And this is equal to -1/2. So we want to solve for theta here. So we want to get the term with theta all by itself. We don't want the tangent theta in the denominator. So we can do that by multiplying both sides by our common denominator to clear our fractions. And our common denominator of both of those fractions is 2 tangent theta. So I'm going to multiply 2 tangent theta on both sides of my equation to clear my fraction. And so doing so, tangent theta cancels on the left-hand side of the equation, and we're left with 2 is equal to, 2 is going to cancel over here, negative tangent of theta. So I want tangent theta, not negative tangent theta. So we can think of it as dividing both sides by -1, or you can think of it as multiplying both sides by -1. And doing so, we get tangent theta is equal to -2. We need to be careful here because when we take the tangent inverse of both sides to get what theta is, tangent inverse, the output is between -pi/2 and pi/2. And so the angle that we're getting is the angle that is in the fourth quadrant, the reference angle. So we just need to be aware of that when we find the answer. So we're taking the tangent inverse of both sides of our equation. And so we have tangent inverse of tangent theta is equal to tangent inverse of -2. So theta is equal to tangent inverse of -2. So when we plug this into our calculator, we get that theta is approximately -1.11. But this theta here, or tangent, this one is contained in quadrant 4. Because tangent is negative in quadrant 4. So we're going to look at changing this. Our reference angle for theta is positive 1.11. And so to get our theta here, what we're doing is we're going to take theta is equal to pi minus the 1.11. So doing so, we get theta, is approximately equal to 2.03.